Okay, the next session will start. We start the session called Rakuten Ichiba Globalization Challenges and Solutions. Please welcome Mr. Olivier.
So good afternoon and welcome to Rakuten Cafeteria. So my name is Olivier, and what I will talk about in this session is Rakuten Ichiba Globalization. So Rakuten Ichiba is our e-commerce platforms. So as you know, we became a global company, and this was not an easy trip. So I will talk about some of the challenges that we faced or are still facing, and some of the solutions that we put in place to address those. So talking about globalization, here I am, French, in Tokyo, talking to a very global audience. But I hope that my French accent will not be the challenge here. Anyway, so before I joined Rakuten, I was working as a consultant in system integration. So I was helping companies to put together their legacy systems and make those very complex systems talk with each other. And since last year, when I joined Rakuten, I'm part of the e-commerce architecture group, and I'm focusing on integrating the different e-commerce platforms of the Rakuten group. So as you know, and Mikitani-san reminded you earlier in his keynote, Rakuten started in 1997 in Japan. And because the business model was very successful, the company wanted to reproduce that in other countries. So the first one was Taiwan Ichiba, opened in 2008. And to accelerate this expansion globally, Rakuten acquired several e-commerce companies across the world. Another milestone regarding globalization was that in 2011, we allowed our Japanese merchants to sell their items overseas and in different languages. And since 2012, with a new e-commerce platform, we are deploying new e-commerce websites in new countries on a faster pace. And at last, since last year, we are trying to unify our e-commerce platforms, because all those subsidiaries, if we can get a unified system, we can get a better user experience. So that's what we are trying to do. Currently, those are where Rakuten has an Ichiba marketplace. So as you can see, it's in Europe, Asia, and the American continent. And to come to that far, there were lots of challenges. Actually, I cannot cover all of those challenges in 1 hour or in 1 day, but I picked 4 themes that I was thinking would be interesting to share with you guys today. The first one is regarding system integration, so how we can have all those legacy systems that have been running for several years or decades come into a single unified platform. Then I'll talk about language, because if we want to allow our merchants to sell their items in different marketplaces, we have to help them translate those item information. Then the third part would be a bit more technical, and about how here at Rakuten we design our system in expandable, which means we can grow, and extensible, which means we can add new features. And I conclude with how we work in a global one team from a system engineer's perspective. So that's a lot to cover. So allow me to start with the first topic, which is system integration. So as I said, we want to integrate our e-commerce platform. Sounds great, right? But it's actually quite difficult. So one of the difficulties that we face is that we have systems that have been running for a long time and that can have features that are not compatible across all other systems. So what do we do with that? Then how well do we know our system? That's a very interesting question that I will provide some elements. And lastly, how do we actually integrate those systems? Well, so we're trying to build a global platform for e-commerce, but there are some features and some ways that business do locally that cannot be applied in a global and uniform way. So when we are looking in migrating systems, we have to think, well, this feature that is great for this marketplace, is it really for this marketplace, or can I reuse it in another marketplace? So should I put it as part of what we call our standard package and that will get deployed all over the world. So that's a very tough topic, and I wish I had a better tip for that. But what we do is a case-by-case scenario with our product management team to see if this, for example, very nice CSV upload function would be nice in other marketplaces or not. And then we put all those features in a backlog and decide, well, to launch, we have to clear the backlog until that point, and then we can launch a new marketplace. So then we can know what we want to migrate or what we want to integrate and define the scope. Then the next thing would be, well, how big are we? How is our system behaving? And what am I going to expect once I migrated? And all systems have metrics, so we have numbers about everything. But usually, a system, we have metrics regarding how it runs, because what we want to know is performance okay? Can I handle the traffic I receive? Is my system healthy? But when you try to compare two systems that have different technologies and completely different implementation, how can you compare those numbers? Because they don't really make sense. So we had an example of marketplace that was supposed to use a backend from a different system. So they were saying, me on my backend, look, on my database, I have 10,000 requests per second, and you only have 5,000. So of course, you cannot handle my traffic. But actually, because systems may have caching layers or totally different way of interacting component by component, we just cannot compare those numbers. So my recommendation is going back to user stories. And we are an e-commerce company, so our user stories look like this in a business B2B2C model. So we have merchants, they own their product data, and so they update their product. So for example, I update my price every day on the merchant UI. And on the other hand, we have shoppers that buy from our mall application. So if we look at those scenarios and we say, look, on this system, we sell 1 million products per day. Or on this system, we have merchants that update 10 million items every single day. Then these numbers can be compared from one system to another, and then we can know what to expect. Okay, so now we know what we want to migrate or integrate and how much and how big is the piece that we are taking into systems. And then we have to think about, well, how do we do it? So in previous companies I've worked in, for example, banking companies, they have so complex systems that cannot talk with each other that they put on top of those systems an integration layer. And the purpose of this layer is only do integration. So that's when you have things like enterprise service bus or enterprise application integration middlewares that become handy. But from what I've seen, what is really difficult when you do these kind of things is governance. Because you have systems that own data and another system that exposes the data. So who is responsible for the data? Is it the system that exposes it, the system that owns it? And usually you have different teams and it becomes really, really complicated. So in our case, we don't really want to do that. What we want to do is to have systems that intrinsically can expose their data through HTTP APIs to other systems, because we don't want to have this integration layer just for this. So how can that help? Well, in the past, for example, 10 years ago, we had systems that were talking to a database. So then we had a second system. When it wants to get the data, it connects to the same database. And if I want to add a new system, well, I connect to the same database. So that's great, except when one of the systems say, hey, I want to change the schema. Ooh. Wait, we're going to have to look into our plan and blah, blah, blah. So it's really complicated. So then engineers came with a great idea of hiding the data storage behind APIs. So then we have all access to the data storage behind a layer that abstracts the data storage, which means if I want to add a new system, well, I just interact with my data APIs. But here in our case, what we realized is the way we define our data is per area. So for example, we have the item data, and then we have the campaign data. So campaign data is, do I have any price campaign related to my item or not? And we realized that nobody wants to access the item data without the campaign data. So we built, on top of the data APIs, higher level APIs that expose what the applications really want, which is the concept, not the way it's implemented in the database. And by doing that, we can have a new application getting the same data in a consistent way. And we can even go further and say, well, on my service API, to have SLAs that fulfill what I want to do, I will add some caching, or I will add some logging, or some priority, or some things that are really service-oriented. Whereas data API's job is just getting the data as fast as it can and making the updates as fast as it can. Right. So yeah, API, it's actually a funny word. When I joined Rakuten, I heard API. So you mean something I put in my source code to package, and that's an API, right? No, that's a web service. So it's funny when sometimes some words are taken from one context to another and becomes the de facto word. So yeah, we have to use APIs and understand it as web service. So the way we use it as our system, and what I said, I don't know what just happened, it's okay, is that we abstract the data layer from the presentation layer. And to go back to original topic of system integration, we can go from, well, I have to integrate my system A with my system B. How am I going to do that? I mean, how am I going to do that? Where do I start? Where do I start? From this to, okay, I'm going to first focus on, let me get my item data and campaign data to my mobile application, and then let's deal, once that's done, with my order data, with my billing system. So by reducing the problem and by moving away from a big bang, let's move everything at once, we can simplify what we want to do and achieve it easier and faster. And it's also easier to test. And testing, so testing is a very complex field. So that's why we have test engineers that are not software engineers. So I don't pretend to cover everything regarding test in this session. I'll just say that regarding integration projects, the way we do it is that we focus on automated test on the UI side, because what we want is a consistent user experience. So we invest on automation once, and then we rerun those tests as long as each release as along the way. Sorry. Okay. So that was for the first one. So the second topic is a bit different. So yeah, my 4 topics are quite different, so the transition is quite hard. But the second topic is about languages. By languages, I mean that we want to allow our merchants to sell in different countries. And we cannot ask our merchants to speak all the languages in the world. I mean, I would hope that everybody would speak French, but I quickly realized it was not true. So we have to help them. So we then give them some automatic translation capabilities. And one interesting fact is when we look at our number, actually 97% of our merchants have their translations done automatically. Only 3% translate by themselves. So it's quite important for our international and global businesses. We started small, so we used translation services that are available, and we quickly realized that there is no perfect translation engine. Automatic translation is a very, very complex field, and so we pick from different services, part of them, and we take the best of them. And we have an advantage, is that we know what we are translating. So those services, translation services, are multi-purposes. So they should be able to translate, hello, how are you, as well as very technical vocabulary. But because we know what we want to translate, we can enhance what their output. So to give you an example, in a Japanese case, there are lots of merchants that use katakana, which is one of the 3 Japanese alphabets, for making their product cool and appeal to the public. But katakanas are really badly translated by translation engines. So we build dictionaries regarding our items to enhance this and provide better user experience.
Do you mean when the Japanese companies write Japanese words in katakana?
Yes.
Because when it tries to translate it to an English word,
Yes.
or a French word.
Correct. And we actually want to go further, and we want to translate images, because we have merchants that do something like this. So they put text on their image. So for somebody who doesn't understand Japanese, I mean, this person wouldn't want to buy this item. Anyway, the person wouldn't want to buy this item anyway. But for my example, we want to extract the text from this image to provide as a hint, well, this is what is written on this image. So that's something we are working at, again, for improving the user experience. Okay, so next topic is regarding system design and implementation. So expandable means that you can become bigger, and extensible means that you can add new features. So those very similar words have actually different meanings that are quite, different. So the way we scale is that we invested on the infrastructure side to build a platform as a service platform. That's the name. So we call it RPaaS, for Rakuten Platform as a Service. And this platform abstracts from the application, the physical layer, the operating system layer, and the VM, the virtual machine layer. So to put it simply, we have an application that could be a Java WAR file or Ruby package that we want to run. So this is what the software engineer produces. So we take this and we push it into the platform. And what the platform does is that it puts this into the runtime. So in this case, if it's a Java application, a Tomcat, then it packages this Tomcat into a virtual machine with some modules, for example, logging, to have centralized logging or monitoring and so on, declares this virtual machine to a load balancer, and if the application developer said, I need 2 of those instances, well, it creates 2. And the beauty of this is that, let's say you have a super sale, so we want to have more computing power. So what we do is, well, give me 1 more instance, and then the platform just gives you 1 more instance. So by doing this, we hide the complexity and the procurement from the software engineers, and the software engineer has only to care about designing a stateless application that can run independently on multiple nodes. Okay. And some other facts regarding globalization is we want to serve customers all around the world. So we use Akamai for caching and serving this. So a user in Europe would get data from a local cache in Europe to have better user experience. And also to be able to globally distribute our system. That's when also the HTTP APIs that I was introducing earlier are very handy, because you can choose where you want to deploy those. And we are currently working on the data storage layer that would also allow us to hide the globalization from the application. So the application shouldn't care about where the data is. That's something that only the data storage layer should care about. So in a globalization environment, if your application supports it, please do scale out instead of just making bigger servers. All right, and so the other topic is extensibility. So there are multiple ways of doing this, and I will just introduce one that I felt and I've seen that is usually underestimated and underused, which is event-driven processing. So what we want to do is we want that when our system grows, be able to add new features without having to change some features that are already in place. We also want to make sure that the new feature doesn't break anything. And we also want to give some additional value to our business. So event-driven processing is a different way of looking at your system. So you have a system when you have users doing something. So the same user scenario as before. So my merchant is updating my product price. So my merchant is updating an order, and my shopper is buying something. So that's one way of looking at it. Another way of looking at it is from the system backend is just, well, an order has been created, or an order status has changed, or a merchant has, an item has been updated. So of course we have databases. So what the shopper does, in the end, it's in a database. So the order information is in a database. But we also produce an event on an event bus that just says, hey, an order has been created. Or hey, my new item has been created. And why is that so powerful is that when you are looking at a big system, searching for what happened in your system is very expensive in terms of resources. At the end of one day, if I want to know how many orders for this particular item were placed, I have to go through my data of one day and pick this one, this one, this one, this one. But if I do it on the fly, when this order regarding this item is placed, I just fire an event, hey, an order for this item has been placed. And that's much scalable and easy to implement and completely decoupled from the transactions that are happening on the system. So in our case, we currently use that, for example, for invalidating cache. So when an item has been updated, there is a system that gets this event and just invalidates the cache. We also send out notification when an order status has changed. And we also rebuilt our search engine index when items change. And all of this completely decoupled from the transactions that are happening on the system. And the last thing I put here is that we could go further and bring new capabilities to our business. But that all depends on business needs. But with events like this, you can go very granular and say, I want to know all the orders for items that are blue. And if that's interesting to your business, you can just, well, have systems that say, hey, a blue item has been sold, just for example. Okay. And the last topic, which is quite different, but as Rakuten grew and became a global company, we have to work as a global one team of engineers. So how do we do that? Well, actually, some people may think that, for example, me, when I joined Rakuten, my English was okay, so I should have no problem working in a global environment, right? But this is completely wrong, because a global environment is not about language, but it's about how we work together. How do we work when we are not in the same office? So of course, language is a tool that we use to communicate as engineers, but still, if the process of assigning tasks or sharing our progress with each other, or even making decisions and sharing capabilities is not in place, English will not help. So that's the things that we are learning, and that we have to educate ourselves and change our processes to work in a global environment. And that takes time, of course. But as an engineer, I have one tip, let's say one tip regarding this from the project I've been running here is that, like I mentioned in part one, we have teams working on their own system. So they have, for them, an understanding of what a concept is. So, for example, a team would think that an item includes inventory. We can have another team, an item, no, inventory is not part of the item. So when the teams are going to talk together, that we get into misunderstanding because they create shortcuts based on what they know. And so it's a very simple thing, but just by creating a glossary and just by saying, hey, for me, an item, that's what an item is. So when I talk about an item, that's what I mean. We can reduce those kind of shortcuts and save time. And that's very, very easy to write. Okay, so I talked a lot about a lot of various things, but if I had to summarize, so first I suggested to describe systems using user stories instead of system-oriented metrics. Then I talked about test automation. Then I talk about automatic translation for merchants. And then I talk about how we use APIs here to make our system integration easier. And also I said that for globalization perspective, scaling out is a good idea, that event-driven paradigm is really powerful. And then I said that we all have to learn how to work in a global environment and also to build a glossary. And that's it for my presentation, but I think we have time for some questions, so if you have any, please.
So now we will have the Q&A section. Is there any questions? I'm sorry, I'm afraid the line is not long enough. Could you come here?
So I have a question. So sure. For the e-commerce, and so people's purchasing activity, so there are many local specific rules. Yes. For example, tax. So how can you merge or solve each local specific designing? So as you said, so just registering and the merchant sending a product is sort of abstract phases, but there are many local specific rules and features. So
of course. So as I said, we try to see if we can make something generic, but if we cannot, we would build something only for this specific purpose, because we have some business units that work in a way that they cannot use the same components than another team that is working in a completely different way. So it's impossible to have a system that you can just, as it is, deploy everywhere and have it work. You have to customize. And it's always the question about how far do you customize or how far do you make something specific. So you can make something configurable or you can make something just for one purpose. But I think there is no truth. It's a case by case, because you're totally right. It's really difficult. There are lots of laws. Laws in Europe, laws in Asia are completely different, right? So we cannot be identical everywhere, but we can try to make the base common, and on top of this base, we build specific features or modules, or call it the way you want. But
so you mean that you have some flexible framework or architecture, so acceptable for each local specific component or services?
Yes, we try to have the backend common, and on top of the backend, we build local components.
Just like SOA or something?
Yeah, you can see it like this. But we try to go a bit further to really have the data layer exactly the same and exposed in a consistent way. But then how the data is used is sometimes marketplace specific.
Okay, so you mean that if you launch the new countries, so you can use a basic system maybe for some registration, but the local teams can add the new local features customized.
Yes. Otherwise, we would have to build a system that is so configurable, like, I don't know, SAP, for example. If you're familiar with SAP, it's a system that can do a lot, but you have to spend 3 months configuring it. So we don't want to go that far. So that's why we still have to develop local features. But we still want to have the common base. Otherwise, systems cannot communicate with each other, and they become too specific. And we lose the benefit of having a unified platform in this case.
Okay, thank you.
You're welcome.
So I have another question.
Please.
Sorry. So what is the best percentage of the automated translation? Because the automated translation is not perfect.
So it's not perfect, but translating manually is expensive, right? So I would say the perfect percentage depends on how much it's like return on investment. If to translate my items by somebody, I have to spend 10,000 yen, for example, but I sell more, maybe I will do it. But that's up to the merchant, because in our system, merchants, they own their data. So we cannot choose for them.
Okay, thank you.
Sorry, just on the same topic, the automatic translation. I was looking at some stuff yesterday on the global site, and I found some very funny translations. And every time I looked at one, I'd find another really funny translation, and I probably wasted half an hour just laughing. Just laughing, not shopping, just laughing.
Shopping is entertainment, right?
Shopping is entertainment, yes. More a suggestion. It would have been handy if there was a button you could click that would flag a translation that was inaccurate. I really liked when I searched for an English word that it translated it into Japanese and found Japanese items that didn't have that word. That was great. But some of the translations back to English were very, very difficult, and it's entertaining, but I didn't end up buying anything.
Yeah, you're right. And we are still working on this translation and find a way to improve those. I mean, we could have some business idea of how to do it I don't know, but sometimes, especially from Japanese to like European languages, for example, it's really, really difficult. And well, it's a ratio, right? But we still have to improve this. It's true.
Thanks for questions. Are there any other questions?
It's a minor topic, but is there any reason to choose HTTP? So I think HTTP is not reliable. Rather than other binary interface.
Yes.
So what is the reason? So logging or implementing?
So the reason, so like I said, the platform as a service platform, the way it was built was to focus on HTTP because the way they can balance the load was very controlled by them. But we could have other protocols. We could, yes. But at the moment, HTTP suits our need and is standard and is easy to have in different data centers. But I agree, we could look into other protocols, and that's something we want to do at some point. When HTTP becomes the problem, we will have to switch to something else. But so far, HTTP is enough for what we are doing. But 100% agree.
Thank you.
Thank you. Are there any questions? Okay, thank you again, Mr. Olivier. Thank you for coming this section, and our next section will start at 5, titled Hackathon Award, Rakuten Technology Award 2014 in the room A, 4th floor. Thank you for coming. Thank you.